Good day and thank you for joining us. In today's lesson, we'll be looking back at our straight line graphs and focusing specifically on the dual-intercept method. So if you can remember last week, we touched a bit on the dual-intercept method and how we would find our two intercepts, hence the dual-intercept method. So we'd find the two intercepts of a graph for the certain equation that's given to us, but what we didn't do is see how we move from there to plotting, okay? So what we're going to do is we're going to look at 3 different examples, and then what we're going to do is work through them systematically. So I'll give you guys some steps that you can follow that's going to help you understand from finding the intercepts to plotting it onto an actual graph, okay? So let's just get straight into example over here. So for the first example, we get given a equation for a straight line graph that is y is equal to 2x plus 6. Okay. So when it comes to dual intercept method, we need to follow these specific steps, and this will help us to understand what we're doing a lot better. Okay. So first thing you need to do is identify your gradient. Okay. So we know that our m, so if we look at a standard form of an equation, we have y is equal to mx plus c, and we know that our m is our gradient, right? So our m in this case is the 2. The m is always in front of the x, right? So what we know about this gradient is positive, okay? So this is, sorry, I didn't mean to put the 1 there. So this is what we're always going to be looking for, whether our gradient is a positive number or a negative number, and this will tell us how our graph is going to look at the end of the day when we are plotting it. So that's always going to be step 1, right? We're going to identify our gradient. With a positive gradient, our graph will head in a direction like this, okay? It's going to head diagonally like this on our graph. So this is how a straight line graph is going to go with a positive gradient. With a negative gradient, it would obviously go the other direction. So let's move on now to our second step. So now we've already identified what our gradient is doing. Now we need to solve for our dual intercept, right? So the way we're going to do that is, let's first look at when we are trying to find the x-intercept of the graph. So when we're trying to find the x-intercept of the graph, we need to make y in the equation equal to 0. So let's go ahead and do that. So we're going to make y equal 0 in this equation here up above. So once we do that, the equation's going to look 0 is equal to 2x plus 6. So all we need to do is get x by itself. So if I do that, obviously the 6 will go over and it will become negative 6, right? So I'm going to write it with the x on the left hand side because it's easy to work that way. And we have a negative 6, right? So all we left to do now is solve for x. So we'll get x by itself by dividing by 2, and we get our x value of negative 3, right? So once we've done that, this is basically our indicator of what our x-intercept is. So what we're going to do is write down the coordinate, okay? So the coordinate in this case is going to be negative 3 and 0. Okay, so that's the coordinate for our x-intercept. So knowing that, because remember, the general layout of this is going to be x and y, right? So we know this is our x-intercept, and y will be 0 because our x-intercept is on the x-axis, okay? And when we have a point on the x-axis, we know that y is equal to 0. Moving on now, we found our x-intercept. Now we need to find our y-intercept. Now to find our y-intercept, it's the complete opposite now. We have to make x equal to 0. So let's see what happens when we do that. So we come back to the equation. We get y is equal to 2. Substitute in 0 in the place of x plus 6. Okay? So once we do that, we get y is equal to 2 times 0 is obviously 0. So we're just left with the positive 6 over there, right? So now knowing that, this x is going to represent our y-intercept. So when we write it out as coordinates, we have in the place of x 0 because it's the y-intercept, and by y we have 6. So just like this, we have our x-intercept here on the left and our y-intercept on the right. Okay, so once we've done that, we can take these values and then we can plot them onto a graph. So to show you guys how we go about plotting this, so we know for we know for number 1 now that our x-intercept we worked out to be -3 and 0, okay? And our y-intercept, our y-intercept is 0 and 6. So what we're going to do now is find these coordinates, okay? So let's use the color blue for number 1, okay? So number 1's line is going to be in blue. So we find -3 and 0 on our graph. So -3 is the x value, so we find -3. And 0 for the y value means we are on the x-axis. So this is the point over here, okay? And what we're going to do is, we always have to identify what that point is, okay? So we will say that this is -3 and 0, okay? And then what we're going to do is find the y-intercept. This is 0 and 6. So we find 0 on the x-axis, so that means we're going to be on the y-axis. And we find the 6, the positive 6, right? So that is our y-intercept over there. So what we'll do also is identify that, of course. So that is 0 and 6, right? And so remember, if you can remember, our first step that we identified is which way our line will be heading. It was a positive gradient, which means it went up like this, right? And if you can see now, when we link up these 2 points that we found, oops, my bad, let me just fix that. Once we link up these 2 points, we can see where our line is headed, right? We can see that it lines up with our gradient, so we know that this line is in fact correct, right? So ultimately there, we've solved for this straight line by using the dual-intercept method. So what you're going to do when it comes to plotting, you're going to plot these points, you're going to identify what these points are, which is always an important step. But what you also have to do is write down the equation for that line, okay? That is going to help them identify which line this is. So right next to it, you're going to write y is equal to 2x plus 6. Why? Because that was the equation for this specific line. Okay, so just running back through the steps again. The first thing we did was we identified with the gradient what the graph was going to be doing. Then we did the dual-intercept method, we found both intercepts. And then what we did was we went to plotting. And once we plotted, we identified which points were plotted where, and we identified which graph it was by writing the equation of the graph. So now moving on to the second example. So in this example number 2, we are given the equation y is equal to 1/4 x plus 2. So as you know, first thing we need to do is identify with the gradient. So this gradient over here is 1/4, okay? So we know that our gradient is positive. Doesn't matter what the value is, we're just looking for that sign in the front. Our gradient is positive, so we know our graph is heading in this direction, right? So that is our first step done. Now we move on to our second step. Let's go ahead and find our x-intercept. So we'll make y equal to 0. So once we do that, we get 0 is equal to 1/4 x plus 2, right? So then we can go ahead and solve for x. I'll keep my x on the left so it's easier. Remember, 2 is going over, so it becomes negative. So once we get there, we need to solve for x, right? How do we get rid of 1/4? We times both sides by 4, okay? Once we do that, the 4 over there will cancel out, so we're left with x is equal to -8. And just like that, remember, we write -8 and 0 as that -8 identifies our x-intercept, so we put it in the place of x, right? Now we find our y-intercept by making x equal 0. So once we do that, we get y is equal to 1/4 0 plus 2. So we know that we just left with that positive 2, so we have 2 as our y-intercept. So we identify that in its coordinate form. That's 0 and 2. Okay, so you can see it's very simple. We're just following our steps, right? Once we make that certain variable 0, we're just following on by solving for either x or y. So now we've gotten our 2 coordinates here, right? So once we've gotten our coordinates, we can head over to the plotting once again. Let's use purple this time. So this is graph number 2. Our x-intercept is going to be, so our x-intercept work out to be -8 and 0, and our y-intercept, we work this out to be 0 and 2. And we also identified the gradient is a positive gradient, so we know our line will be heading in the same direction as our first graph, right? Because it's still a positive gradient. So what we do from there is we find our points on the graph as we did before. So we find x, and x is -8, which is over here, and y is 0, so we stay on the x-axis. So we have this point as -8 and 0. Then we find 0 and 2, so 2 on the y-axis, right? And 0 is x, so we stay on the y-axis. That's 0 and 2. And then all we have to do then is link up these 2 points to find our line. Now if you can remember, let me just complete this line for you guys. So you'll see the difference in gradients, okay? Remember the gradient of this first line over here, it was 2, right? So we can see that it has a much steeper line, but this gradient was only a quarter. So we can see that the gradient is not as steep, right? So that's just how you can tell with difference of gradients that your graphs are actually right, okay? So obviously once we've plotted the graph and drawn it in, we need to write in the equation, right? So this equation was y is equal to a quarter x plus 2. Okay? So just like that, we've completed the second graph as well. So nothing difficult about it. All we're doing is following our steps, okay? So now with that, we'll look at one more example. It's number 3. So we'll be looking at something a bit different, okay? So we get given 4x plus 6y is equal to 12. So in a typical example like this, we're given a equation which they say is for a straight line. But what is up to us to do is to find out the equation of the straight line, because we can see that this is not in the standard form that we used to. And what is that standard form? It's y is equal to mx plus c. So what it is up to us to do is to put it into that specific form. So the way that we're going to do this is just looking at how this equation is set out. We can see that y is on the left hand side, right, of the equal to sign. So we have this y over here, so we'll keep it as 6y on this side is equal to mx. So that's going to be our 4x over there. So what's going to happen is the 4 is going to come over the equal to sign. So we're going to have negative 4x, right? And 12 is going to stay there, so it's going to be plus 12. Okay? So once we've done that, we can see that this equation isn't in its simplest form. And remember, if we're working with y as the subject of the equation, it needs to be in its simplest form. Okay, so we need to basically just solve for y, or get y by itself. So what we're doing is we're dividing by 6. Okay, but what we're doing to the one side, we have to do to the other side in each term on the other side of the equal to sign. So once we do that, we obviously get y as itself. We get left here with negative 4 over 6x, right? Which can be simplified into negative 2 over 3x, okay? So you can see what I did there. I just simplified this fraction that is over here. into negative 2 over 3x plus 2. So as you can see, we've converted this equation into standard form for a straight line, and we've simplified this equation down. Okay, so this is going to be our final equation that we're working with. So from here we can follow our steps as we would as per normal. We'd identify with our gradient. In this case, we can see our gradient is actually a negative, and we know with a negative gradient we're going to head in that opposite direction to a positive gradient, right? So our graph's going to be heading in this direction over here. So that's going to be our step 1. Our step 2, we're going to go ahead and solve for that x-intercept. So we'll make y equal to 0. So we get 0 is equal to negative 2 over 3x plus 2. So we have to get x to be a positive, so we're going to take that over now. And that's going to be 2 over 3x is equal to 2. Now there is a two-stage way of getting x by itself over here, because we have not a basic fraction with a 1 as a numerator. Okay, so the way we're going to do this is we're going to first get rid of that denominator as we usually do. So the way we can do that is timesing both sides by 3. What that does is it cancels out that 3 at the bottom, so we're left with 2x here, and we have 6 on this side, right? 2 times 3 is equal to 6. And then we have to get x by itself one more time, and that we do by dividing by 2. And so we get x is equal to 3, which represents our x-intercept. So we have 3 and 0. Okay? So just like that, we have our x-intercept. Now, finding our y-intercept, we make x equal to 0. So we have y is equal to negative 2 over 3 times 0 plus 2. Okay? So we just left with y is equal to 2. So we have our final one there of 0 and 2, right? That is our final intercept over there. That is our y-intercept. So now we have our rule for our gradient. We have our two intercepts. So let's head over to our graph for plotting. Let's see if I can work with the space that I have here. So we have here number 3 now. And our x-intercept that we've worked out. This is going to be 3 and 0. So you can already start to see like the difference in the values of the intercepts, right? Because now we're dealing with a negative gradient, we can already see our x-intercept is a positive number. And then we have 0 and 2. Okay? And we've identified with our gradient that we are heading in this direction. Okay? So now heading over to plotting, we're going to plot the x-intercept of 3 and 0. So we have 3 over here, and that's 3 on x-intercept on the x-axis, and y is 0. Okay? And then what we're doing is we're going to plot that y-intercept, which is 2 on the y-axis. Okay? And 0 on the x-axis. So we're going to link up those 2 points. And just like that, we have our final straight line graph. Okay? Just identifying these points once again. This is 3 and 0. And this is 0 and 2. Okay? Always important when we're plotting, we need to identify the points we're plotting. And then our final step, of course, is writing in that equation. And we're going to put in that equation that we found. Okay? Because remember, we had to convert that equation given to us into standard form of a straight line. And we got it to be y is equal to negative 2 over 3x plus 2. And just like that, we have finished off these examples. So, very important things to note. Our first step is always going to be identifying with that gradient, okay? Moving back over to number 1. Identifying with that gradient, what we are going to be doing with the graph. A positive gradient is heading in this direction. A negative gradient is heading in the opposite direction, okay? Then we're going to solve for the x-intercept. We're going to make y equal to 0. Then we're going to solve for the y-intercept, making x equal to 0. Once we've done that, We head over to our graph, we start plotting, okay? We find the 1 point, we find the second point, right? Then we draw a line in, we identify what these points are, and then we identify which which graph we're doing, okay? By putting in that equation of that straight line. But anyways, that is going to do it for today's lesson. I really hope that it helped a lot with understanding the dual intercept method, and we look forward to seeing you in the next video.